Hello everybody, welcome to my channel, and today we'll talk about naming of organic compounds. And first of all, let's talk about IUPAC rules and then take some examples of organic compounds and name them. So according to IUPAC rules, so the first what you have to do is to find the longest carbon chain, and this chain will be the base of compound's name, or it can be called like a skeleton. Then you have to number the chain. You start the numeration and write the number of the carbons, and you have to start from the end that is closest to a substituent or to a functional group. Third, you have to identify and name the substituents. Assign a locand to each substituent, indicating the position of the substituent on the main chain. Then you have to specify multiple substituents. For example, there can be several substituents of the same type. For example, 3 methyl groups. In this case, you will use numerical prefixes such as D, tri, tetra, etc. So you will use Latin prefixes to indicate their number. After that, you have to determine the parent name. Like the parent name is based on the type of carbon chain. For example, it can be alkane, alkane or alkene, etc. So the parent name is derived from the number of carbon atoms in the chain. Then you have to indicate the functional groups. If there is a functional group present in the compound, it should be named and located using a prefix or suffix. It's like we have alcohols, that will be the suffix ol. Aldehydes will have the suffix al. Carboxylic acid will have the suffixes oic acid. And amines we will just use the word amine, among others. Let's see then what you do. Further, we have to consider cycloalkanes. You will see a cycle, we see that this is a cycloalkane. We will use the prefix cyclo before the parent name. And then we have to arrange alphabetically. Like when we arrange names of substituents, we use the alphabet order. When multiple substituents are present, you have to arrange their names in the alphabet order. But you have to ignore any prefixes like D, tri, etc. For example, you have the prefix like D-methyl. You do not consider D, you consider like methyl, M. You consider the letter M, not D. You should not forget that you have to use hyphens and commas. Hyphens are used between numbers and letters in order to separate them from each other, while commas are used between numbers to separate them. Here you can see the foundations according to each number of carbon. So when you start the numeration, it should start from the end that is closer to that part where there is a functional group or a substituent or something. But what we do, we have several functional groups, several substituents, etc. We use priority. So if you have several functional groups and substituents, you have to define which of them has a higher priority. And here you can see the table of the priority. Which functional group has a higher priority than the other one, so you can look and get familiar with this table. Well, and now let's take an example. Let's say we have such a molecule and we have a double bond here. So double bond in our case is a functional group. We have only one functional group. And the numeration in this case, it doesn't matter from which side we start the numeration, because the double bond will always be on the second carbon. That's why let's start from left to right. And right, 1, 2, 3, and 4. It's alkane. We said that if we have 4 carbon, the foundation will be but. It will be butene. We have to indicate at which carbon there is a double bond. Since it's at the second carbon, we write but 2 in. Well, now let's take another example. For example, let's suppose we have such a molecule. Let's see. Here, functional group is OH, hydroxyl group. And we can say we have hydroxy group, it's an alcohol. So the numeration will start from the side that is closer to the functional group. It's an alcohol. We have 5 carbons, so we will use the foundation pent. We see it is a pentan, but it has a hydroxyl group, so it's pentan, pentanol. The hydroxyl group is on the first carbon, so it will be pentan 1-ol. Well, let's take now another substance. Let's take such a molecule. A bit more complicated. Let's see what we have here. So we have, let's say, the double bond. We have also substituents like chlorine, ethyl, but the double bond has a priority over the other substituents. That's why the numeration will start from the side that is closer to the double bond. Double bond means that this is an alkane. So it will be, if it's 6 carbons, it will be hexane. But let's now name also the substituents. Let's see. We have 2 chlors and 1 ethyl. Let's start now naming. You see, we go in alphabet order. C comes before E. So chlor will start first. So on the second and on the third carbon we have chlorines. We have 2, 3. Dichlorum. Then on the next one, on the first carbon we have ethyl. We write 4 ethyl. Then we said we have 6 carbons, so it's hex, right? The double bond is at the second carbon, so we write 2N. So it will be 2, 3 dichloro, 4 ethyl hex, 2N. And now let's take an aromatic substance, aromatic compound. Let's take it. Let's see which functional groups we have. We have aldehyde group, hydroxy group, we have NO2, and we have ester group, OCH3. Let's first write the radicals here. Then if we write the priority from the previous table, we will see that the aldehyde group had the priority over all the other ones. That's why the numeration will start from the side where we have the aldehyde. And we will go in the clockwise direction because in this part there are more substituents. So let's do the numeration. 1, 2, 3, 4, 5, 6. So it's al, because aldehyde. 2 hydroxy, yes, because on the second we have hydroxy group. 5 methoxy, because it's methoxy. Why methoxy? Because it's ester. Methyl, ester, methoxy. 3 nitro. Then let's see, it's aldehyde, and it's on benzene. We say benzoic aldehyde or benzaldehyde. You can write benzaldehyde or benzoic aldehyde. Now pay attention. Why first we write 5 methoxy, then 3 nitro? Why do we not write 3 nitro, then 5 methoxy? It's because we go in alphabet order. M comes before N. And that's why we have to follow this alphabet order, and we have to write as 5 methoxy and then 3 nitro. Do not forget to follow the alphabet order, always. Okay. Now let's imagine we have this molecule. Let's see what we have. 1, 2. We have 2 functional groups, a double bond and a triple bond. The double bond has a priority over a triple bond. and that's why we start the numeration from this side, from this part. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's start numeration. We have 1 ethyl group and 3 methyl groups. So let's say ethyl and methyl. So E it precedes M in the alphabet. That's why first of all we will start with ethyl. We will write 3 ethyl, then 4, 5, 3 methyl. After that we have 9 carbons. It will be non, 2 N, because on the second carbon we have the double bond, 2 N, and 6 in, because on the 6th carbon we have a triple bond. E, M. You see, we don't consider 3. We don't consider the prefix when we pay attention on the alphabet order. Let's now take something more complicated. Let's write it in this form. Actually, usually in organic chemistry, compounds are written in a zigzag form in this way. This is the most stable form of any compound. That's why you can see a lot of such types of writings. If we write it in such a zigzag, we should know that in every nodal, I will make them purple, you see, there is a carbon. Look, you see, if it's a carbon, it has 2 bonds, it means it has also 2 hydrogens. We don't write carbons and hydrogens. We have 1 carbon, we see there are 2 bonds. When our valence is 4, it means that the 2 other bonds will be spent for hydrogen. So it will be CH2. So we just should know that in every nodal there is a carbon. And the number of hydrogens can be found from the number of bonds and valence. Let's see. Look, we have 1 functional group, not functional, we have 1 substituent, 2 and 3 substituents here. But look, this side, which I make yellow, is closer. It's more comfortable, it's closer to start from here. So we start the numeration in this direction: 1, 2, 3, 4, 5, 6, 7, 8. Here we have methyl. Why? Because we write nothing. It means there is 1 carbon. In this nodal we have 1 carbon. And it will be CH3. It's methyl. On the 6th carbon we again have a methyl. Let's see what we have on this first one. Look, 1, 2. We see that we have 2 carbons here and OH group. That means it will be 2 hydroxyethyl. And it's on the 4th carbon. So 4, 2 hydroxyethyl, then 2, 6 dimethyl, 8 carbons, octane. So let's see in substituents H and M. They come in alphabet order. Let's see this example. Again, just we start the numeration. Yes, we have methyl and ethyl. It will be 4 ethyl. You see in the first one we have an ethyl because there are 2 nodals. In each of them there is 1 carbon, so it will be ethyl. 4 ethyl, 2 dimethyl, heptane because 7 carbon. What can you see now? You see it's a carboxylic acid. Let's write such substituents. Okay. So we have 2 substituents like chlorine and 1 functional group. We know that carboxylic acid, functional group, carboxylic groups have a priority. That's why numeration starts in this direction: 1, 2, 3, 4. And now let's write. It will be 2, 3 dichloro. Then we have 4 carbons. It's butanoic, OIC. Decided to mention the acid, carboxylic acid. It will be butanoic acid. Well, that's all for today. If you wish, I can prepare another video with more examples, with more compounds, and name there. If you wish, write in comments and I will prepare a new video with more examples. Well, subscribe the channel and see you in the next videos.